So let's see, today's Monday, so we're doing the first homework of the weekend. This is the video. All right, so this week's homework is straightforward. We're simplifying fractions in a way that even though we didn't start about simplifying fractions in class, you can actually do it, okay? All right, so I'm gonna give you two types of questions to do, all right? And the first one is where you can only simplify once, and the second one is where you can simplify multiple times. Okay, so that way you won't get caught not knowing how to do one or the other. Now here, all right, so we have a question that wants you to simplify the fractions, right, by using it graphically. And I think that by doing it at home, it's a good way for you to practice and understand what simplifying fractions really is about, because this thing has a really cool animation here that allows you to see it in its entirety, how this whole thing works. And so let's take a look, all right? So here we got a question, all right? They're all circle graphs, by the way, all right? And the question is, how much of this entire circle graph is shaded as a fraction? Now, if you take a look, how many total pieces are there? There are 16, right? So 16 will be our denominator. And how many of them are shaded in blue? 10, right? So it's 10 out of 16. So 10 over 16. So they want the original fraction first. So don't simplify it right off the bat. All right. Now, what's a common factor? So remember the lesson we had in class the previous week, right? What's a number, in other words? What's a number? Let me fix my hair. What's a number? Very nice. All right, what's a number that goes in both 10 and 16? What's the only number that goes in both 10 and 16? Yeah, 2, right? Because they're both even numbers. So I'm going to press try. And then we'll now watch the magic. Okay. It's not doing anything. Why is that? Something is stuck. What's happening? Okay. Wow. Okay, wasn't sure what happened there. Right? So now you're dividing everything by 2, right? By everything, I mean numerator and the denominator. And so what's the new fraction? Well, out of the 8 parts, how many of them are shaded? 5, right? So it will be 5 out of 8, like that. Okay? And I think that's it. All right? Okay, this computer's a little glitchy right now. There we go, all right? Now, a second type of question could look something like this. Okay, let me see. All right, not this one. Let's find another one. Some of these, it's a lot, okay? But they count them for you, so you know what I'm saying? All right. Okay, this one is good. Yeah, okay, this one's good. Now, if you take a look at this question, what's the original fraction? Yeah, it's what? 18 out of 27, right? Now, for those of you who are more advanced with the simplifying the fractions and really with common factors, what's the greatest common factor, okay? And don't jump to conclusions yet, just hear me out. What's the greatest common factor between 18 and 27? It's 9, right? Now, I'm not pressing enter here because what I want to show you is you can actually reduce this twice, meaning you don't have to use the greatest common factor, as I show you in class already. So what's another number that's not as big as 9 that can go into both 18 and 27? Yeah, 3, right? So meaning you have to do it multiple times. I think you can see that. So I'm going to use 3. I'm going to use a smaller number. All right, so look at the cool graphic here. All right, so now we have a new fraction, right? Even though it's equivalent, right? It's worth the same, equal in value. 6 over 9, right? That's the new fraction. Now, that's not the simplest form. You know that. What's another number that goes into both 6 and 9? Yeah, it's 3. So you see how we have to do this twice? And then finally, after this, we have our simplest fraction, right? Which is what? What do you think? Yeah, it's 2 over 3. That's our fraction in our simplest form. So now, could you use 9? Yeah, like the computer on Delta Math, if you had used 9, meaning going from 18 over 27 all the way to 2/3, it's fine. It's not wrong. I'm just telling you that there are other ways of solving it. That's all. Okay? And either way, you won't be wrong. That's also what I'm trying to tell you. All right? And that's it. Okay. All right. Thanks for watching. Have a good day. And see you in class tomorrow. Okay? All right. Bye now.
OMG, that was so good.